Okay, so what we're working on with this activity is just doing some vector stuff, but without having to do vector problems for days on end. You can work with some people, get some socialization, and do a little vector, plus a little bit of review of b equals d over t. Okay, so overall, we're trying to plan a route between some locations that I will have marked on the maps that you will get. Okay, and the first thing you want to do is plan your routes. Okay, just draw on how you're going to walk, okay, from A to B, or from 1 to 2, and then from 2 to 3, and then from 3 to 4. Okay, plan that out. Now, you do have to take a few things into consideration when you're planning your route. You can't fly, you don't have a boat, or a car. Okay, now I say that because if you look on this map here, okay, you will see that there is a road that is basically of no use to you. We're not going much near that road. Okay, there are rivers. Okay, that's all those squiggly blue lines. Okay, those would all represent rivers, and your maps are in color. And then there's the contour lines that I think we talked a little bit about on Friday, right? The closer together the contour lines are, the steeper that is. If they're right on top of each other, it's a cliff. Okay, and you can't climb the cliff. You have no climbing gear. Okay, so you can't also rappel down the cliff or jump off because you can't fly. We covered that earlier. Okay, so all of that stuff is important, okay, to keep in mind. Now, you will also see that on the map there are some dotted lines. Okay, those dotted lines are actual trails. They're much easier to walk on, so you generally go faster when you're on those trails. Okay, now that doesn't mean that you can't go off the trail. In fact, I will force you to. Okay, there will be some points where you will have to bushwhack. Okay, that is much slower. Okay, and so as a result, you will go slower. Okay, you will have a slower speed through the trees when you're off the trail. Okay, and if you're off the trail and you cross a river, there won't be a bridge because they only build those where there's a trail. Okay, so if you have to cross a stream, that takes a little time because you have to be careful. Okay, you could get swept away if you're not careful, and that would be bad. So crossing a river where there's no bridge takes an extra 15 minutes. You add 15 minutes onto your total time for the day every time you cross a river when you're not on a trail. Okay? So it adds up after a while. Okay, so here's what I'm looking for. Like if we're looking at day 1, for example, the most obvious way to get from start to cabin 1 is to follow this trail. Agreed? Right, so everyone's going to have the same path that day. Everyone is just going to go, all right, Coder, I'm just going to be smart, and I'm going to follow this trail, right, all the way up to cabin number 1. Okay? Now, you're going to need to measure that. Okay? Now, a good way to measure that is usually with like a headphone cord or some kind of power cable or something like that, you know, that you can use. Maybe you've got a charging cable or headphone cord or something like that. Okay? And what you do is you just put it on the paper. I can't put it on the screen because it'll think I'm trying to write on it. Okay? But just put it on the trail and kind of generally make it take the shape, follow all the curves, right? Then grab the 2 ends, straighten them out, and you'll all have a meter stick. Okay? You can just measure this. And that'll tell you your displacement after you multiply it by 500. Okay, because this map is obviously a scale of 50,000 to 1. Okay, so that means 1 centimeter on the map represents 50 meters in reality or something like that. Anyway, okay, we'll get to the scale in a minute. Okay, want to follow how we would measure that? Okay, because that's going to be a distance. That's what kind of quantity? Scalar. Yeah, that's a scalar quantity, right? You went a whole bunch of different directions on that trail. This just says how far did you have to walk from start to cabin 1. Okay, so that's the first thing you're going to measure. The next thing you're going to measure is you're going to put the displacement on here. Okay, well the displacement is just that line. Okay, now you can measure it. That'll get you its magnitude, but what else do you need? You need direction. Okay, well conveniently, this map has grid lines on it that go north-south and east-west. So all you have to do, okay, is draw on here your north component and your west component. those, if you measure them, you can use in a trig calculation. Right? And you don't even have to convert them to meters. You don't have to do the scale thing. Right? Trigonometry will already do that for you. Okay? All you have to do is take those two numbers and get the angle. Then you've got your displacement, magnitude, and direction for the day. Okay? So I'm looking, those are the first two things I'm looking for you to do. Distance and displacement. Okay? Next thing I'm looking for you to do is calculate the total time that you walk for the day. For day one, it's really easy, because you're going to walk on a trail. So you're going to walk at the same speed all day. And you know, because you've already measured it, how far it is. So if you already know D and V, can you calculate T? You can. Now, you're probably going, yeah, Codere, you're going to tell me how fast I walk? Well, I do actually. If you look at the instruction sheet, that one, okay, you will see that the speed is one of the rules. Okay, because there are rules to this assignment. Okay, the first rule is altitude affects speed. So if you are on the trail below the tree line, that means you're in a green part of the map. Okay, that's below the tree line. You can walk at 1.5 meters per second. If you are on a trail above the tree line, you can walk at 1.2 meters per second, because oxygen gets thinner and you get slower. Okay, if you've ever done any climbing or hiking in the park, you know. Okay. Second rule, the bushwhacker rule. If you go off trail, you slow down. Okay? So if you are off the trail below the tree line, you can only walk at 0.75 meters per second. Okay? Because it's a lot slower when you're walking through the bush with no trail. Okay? If you're above the tree line, you can actually walk at 1.0 meters per second. Wait a minute, didn't we just say altitude affects speed? How do you walk faster when you're above the tree line? There's no trees, exactly. And you slow down a little bit just because there's no trail, but there's also no trees, so it's not as big a deal to be off the trail above the tree line. Okay, so now you know your speeds. Now, here's what you probably want to do on the map. Okay, I would say if you got somebody who's got different colored pencils or pens or something like that, I would mark different speeds in different colors. Okay, so if I know, let's say I'm walking over here, okay, where we actually don't do any walking for this activity. Okay, so let's say I'm on this trail here, okay, and I'm walking along this trail, and then I just decide, all right, I'm gonna putter over here and walk this way for whatever reason. I use a different color. I know that's going to be 1.5 meters per second, but that's going to be 0.75 meters per second, and I would measure them separately. Okay, so that I can calculate how long each part of that takes. Does that sort of make sense? All right, and the last rule is the silly salmon rule. Okay, you are not a fish. Thank you, Rachel. I'll take that. Okay, you are not a fish. Therefore, if you cross a river off trail, you will add 15 minutes to your total time for the day for each stream crossing. Okay, because in real life, if you're doing a stream crossing, you probably don't want to get your socks wet. Okay, maybe you're taking your boots off, you don't get them wet, and you've got your water shoes to go across the river. Okay, crossing a raging river with a heavy pack on is not something you take lightly. Okay, you want to be careful in doing that, so you add 15 minutes to the total time, just to bring an element of reality, okay, to this little endeavor. Okay, so for each day, I am looking for distance, displacement, total time, average speed, and average velocity. Okay, now spoiler alert, for day one, your average speed is 1.5 meters per second. Why? Yeah, you spend the whole day on the trail. You never do anything other than walk at 1.5 meters per second. Okay, so you're good on that one. Okay, there's no real calculation involved. But when you start getting days where, oh, okay, well, I could only walk this fast, and then I walked here, this took longer than this, okay, it's total displacement over total time, or total distance over total time if you're calculating speed. Okay, making sense? It's just a little bit of review of V equals D over T and some vector stuff. All right, so I would say your best bet for a way to arrange all of this, okay, would be just set up like day one, okay, show me your calculations. Okay, I do want to see your calculations. right? Because if I look here and the answers don't look right, I want to be able to go back and see why they don't look right. Maybe you just took a really weird route, okay, and I need to look at the numbers, right? But that's what I should see in the end for each day. Day 1, average velocity, total displacement, total distance, average speed, and total time. And I'm also going to want that for the whole trip. Okay, so the whole trip, you're going from start to 5. Okay, to get the total distance, what do?
Add them all together.
Add all the distances together. Yep. Okay, that's an easy one. And for the total time, add all the times together. Yep, pretty simple. Okay. Now, for the total displacement and average velocity, you need to draw what? Yeah, you need to draw a vector, right? It goes from start to 5. You need to figure that one out. You need a magnitude and a direction, okay, so that you can get the average velocity, okay, and total displacement from start to 5. Okay, so you're going to have a day 1, okay, as I showed you here. Okay, so you're going to have day 1 numbers, day 2 numbers, day 3 numbers, day 4, day 5, and total trip. Okay, all of those same things for each day. It actually says that on there, so you can always refer back to your instruction sheet if you're, did I do everything? Guys, the most common mistake here, okay, these are the 2 most common mistakes on this assignment. Not doing one of those 5 things, okay, and not putting vectors on vector quantities. Okay, now, to save you a little bit of time and remind you of something, if I calculate the vector for my displacement, what is it the same as? What else for that day would have the same vector? The velocity, okay? Your displacement and your velocity will have the same vector. Please write it for each of them. Yes, it's the same number, but it applies to both of them. Put it on both of them, okay? You only have to calculate it once is what I'm saying. Okay? All right. Any questions on what we're doing? Okay, if you don't have a headphone cord or a power cable or something like that with you, okay, a shoelace will work, a drawstring from a hoodie will work, okay? Anything you can make take the shape of that path will work, okay, for measuring the distance. All right, you have the rest of class today and probably half to 2/3 of class to work on this. So let's get together in groups. Group size is 2 or 3. Okay, in a group, please make sure everybody's included. Okay, if you're doing this on your own, you don't want to do this on your own. It's way too much work. So please just join a group. If you don't have a group, I'll find a group for you. Okay, let's just try and make sure everybody gets included. Okay. There's not enough work for everyone in a group of 4. There's too much for a group of 1, and there's not enough for a group of 4. So 2 or 3, I will accept. Just like the holy hand grenade. Okay? 3 will be the number of the counting, and the number of the counting shall be 3. Okay? All right, get together. Oh, sorry, maps. Okay, so each group, just send one person up here to get the map. I'll put some tape out, guys, because you're going to want to tape these together. Which one? No, I meant for you to keep it. Yeah. Yes. Oh, no, you got Okay, guys, there is tape up here at the front. Please make sure it stays up here at the front, but you'll want to tape those maps together. You may also want to trim some of the white off the sides of them so you can actually fit them right together. You may. You may.
Those are my cards.
Okay, so I think no, I think we just we might have to follow the just taking sure, yeah. And they're like so reading about this, and be responsible.
Why do you have green? Those greens like that three, so.
They are sometimes a blessing.
Oh, never mind. Is it green here? Yeah. Apple girl, I'm going to take one. Well, we just have to follow one trail.
Yes, yeah, one per group. Yeah. Sorry guys, good question just came up. I forgot to address it. Yes, you are submitting this as a group, so I only need one copy of the map and one copy of the calculations. Oh, it's supposed to get the, yes. Thank you for reminding me.